Hey everyone, what is happening? So we had a little bit of a Microsoft Teams meeting today, and we chatted a bit about the female hormone releases. And so I'm just going to recap that, and everyone can check this out. So I'm going to start by drawing a bit of a brain. So there's our brain, and in the very middle of our brain, right about here, we've got the hypothalamus. And then just below the hypothalamus, we have the anterior pituitary and the posterior pituitary. And so right here, anterior means front. So this is our anterior pituitary. And right here is our posterior pituitary. Now, what happens is, remember we're talking about female hormones, and this is very similar to male hormone release. So the hypothalamus is going to release, just like in males, gonadotropin releasing hormone. And it does the exact same thing, or it targets the exact same thing as in males, and it targets the anterior pituitary. And it causes the anterior pituitary to release two hormones that we know all about already. It targets it, and it causes it to release follicle stimulating hormone, FSH, and also luteinizing hormone, which is LH. Now, we're going to take a look over here for a second, and you can see that we've got luteinizing hormone and follicle stimulating hormone right here, and we're going to relate this to the developing follicle. So if we just go down a little bit, I'm going to draw an ovary. And so there's our ovary, and what we have to think about here is the fact that the anterior pituitary is going to release FSH, and this follicle stimulating hormone, this causes our primary oocyte to start to develop. So remember that all our eggs are already in the ovaries, and they are in meiotic arrest, and so they've gone through meiosis 1, and as soon as they get fertilized, they will go through meiosis 2 so that they get full chromosome reduction. All right, so follicle stimulating hormone stimulates the primary oocyte, and it causes the follicle to develop. Now, we talked about this in the fact that the follicle is going to start to release estrogen, and it does this because it's got little granulosa cells all around the follicle. So this would be day 1 right here, and you can see that over here it's a very small little follicle. All right, and so now what happens is this developing follicle is going to get bigger and bigger. So let's draw this, and we've got our little egg here and the follicle around it, and the follicle is made of these cells called granulosa cells, and what these do is they produce estrogen. Okay, and the estrogen has many different effects. One of the effects is that it also causes more development of the granulosa cells, so a bigger follicle. And so what happens is this follicle moves along and gets bigger and bigger, like this, until about day 14, when it bursts, and we're going to get there in a second. Okay, so the granulosa cells make the granulosa cells produce estrogen, and it starts with a very low level at the beginning, and it moves along until about day 13. All right, and so day 13 we see a spike in estrogen, and you can see this spike right here. Okay, so this is from the granulosa cells. Now, I'm just going to move this up a little bit, and what happens is you can see this spike in estrogen causes a spike in LH, and you can see that we've got LH right there produced by the anterior pituitary. So this spike in estrogen causes a spike in luteinizing hormone, which causes the Graafian follicle to burst, and then the egg goes into the fimbriae and then to the fallopian tubes. Okay, so it hangs out in the fallopian tubes where the cilia inside the fallopian tubes kind of bring it in, and it waits there for about 24 hours. Now remember that the egg develops in the uterus and it only finishes meiosis when it gets fertilized. Otherwise, if it doesn't get fertilized, it just gets released along with menstruation. All right, so let's take a look at this picture. What is estrogen doing here? So estrogen has increased, it's gone up, it's increased, and it caused a surge in LH. And so then now what we get is we get the follicle turning into the corpus luteum. And this is right here. And so the corpus luteum is now going to secrete estrogen and progesterone. I just want to bring your attention to the fact that estrogen also helps develop granulosa cells, but it also develops secondary sex characteristics, and it also thickens the endometrium. And you can see that right here. You can see that right here is that as we get more and more estrogen from the granulosa cells, it starts to thicken the endometrium. All right, we're going to go back to the first 5 days in a sec, but it thickens the endometrium. So now we have ovulation, and the egg goes off into the fallopian tubes via the fimbriae, and then but the corpus luteum is still working. So here's our corpus luteum. It's still working, and now it's going to start to produce estrogen and progesterone. Okay, so this is the luteal phase, and you can see the corpus luteum over here, and it's producing progesterone and estrogen, and this is called the luteal phase. So the corpus luteum produces estrogen and progesterone, and it helps build up the endometrial lining, as you can see over here. It builds it up even more. So we get a thickening of the endometrium. We also get increased vascularization, which means more blood vessels, and we also get increased in mucosal secretions. Now, what's really interesting about this is the fact that this combination of estrogen and progesterone tell the hypothalamus to stop producing gonadotropin releasing hormone. This is a negative feedback loop. All right, and so this is so that we don't produce another follicle while one could still be in the uterus. Now, just going back, this estrogen, we get that buildup of estrogen. This was a positive feedback loop, okay, up to a certain point. So it caused the hypothalamus to produce more and more gonadotropin releasing hormone, and you can see that it produced more and more up until that point, so that there was enough estrogen to cause a surge in LH. And then it turns into a negative feedback loop with that combination of progesterone. So now what we have is at the very end of our cycle, so about 28 days, and I'm just going to go back here. And so the corpus luteum got smaller and smaller, all right? And what happens is it starts to produce less and less hormones, okay? And so now we know that negative feedback loop, if it's producing less and less hormones, then the hypothalamus turns on again and starts to produce gonadotropin releasing hormone, okay? And so then a new follicle is going to start to develop. But in that time, there's not enough hormones to maintain the endometrial lining. And if someone's not pregnant, then this is shed in the first 5 days of the cycle. Now, if someone is pregnant and the egg is fertilized in the fallopian tubes, then what happens is the corpus luteum is maintained. So the fertilized egg, once it implants, it will produce human chorionic gonadotropin hormone. And what this does is this causes the corpus luteum to be maintained so that the endometrium lining will be maintained. And this is also why, for the most part, people won't get their period when they are pregnant because the endometrial lining is being maintained. All right, so what have we learned today so far? We've got the hypothalamus produces gonadotropin releasing hormone. The anterior pituitary, which it targets, the anterior pituitary is targeted by the GnRH, and it produces follicle stimulating hormone and luteinizing hormone. The follicle stimulating hormone right here, it stimulates the follicle to grow, and it produces more and more estrogen because the granulosa cells. All right, so once it gets to a certain point, it's going to cause a surge in luteinizing hormone. Okay, so that's a positive feedback loop. And then the luteinizing hormone causes the follicle to burst, which is ovulation. The egg goes into the fallopian tubes and could get fertilized. Now, once we get past ovulation on day 14, the follicle turns into the corpus luteum. The corpus luteum then starts secreting estrogen and progesterone, which causes the endometrium to thicken and have more vascularization and more mucus. This is preparing it for implantation. Now, if implantation does not occur, then over the course of approximately 14 days, this period right here, from day 15 to 28 approximately, the corpus luteum degrades and the amount of progesterone and estrogen starts to go down, which then doesn't support the endometrium lining, and it is shed in the first 5 days of the cycle. Now, if implantation takes place, then the fertilized egg / placenta, it produces human chorionic gonadotropin hormone, which maintains the corpus luteum for the first 3 months, and the corpus luteum produces estrogen and progesterone so that the fertilized egg can survive. All right, email me or message me, or we can have a meeting on Teams if anybody would like to go over that. All right, good luck. Take care.